Okay, today I want to introduce you to System Recorder. Um, so, so we talked a little bit in the last video about data flow analysis. Data flow analysis is a small portion of this entire system recorder. Uh, we will talk about system-wide recording and simplified analysis. These are marketing terms. So system-wide recording in general just refers to collecting a lot of different data, so the PLC logging information, all the device information, maybe servo status, a video feed from an IP camera, and operation from an HMI. So did the operator press buttons, etc., bringing it all into a central location, and then sharing that information. So again, system-wide recording is a kind of a generic term, as well as simplified analysis. So again, generic, what that does is it takes GX Works3, so we can have ladder monitor, we can have the data flow analysis, which we've already looked at, we can have a video feed, and then GX log viewer, and we can sync all of this together with a seek bar, and so that the data will all be synced up. This is showing system-wide recording, again, the marketing term, and the simplified analysis, and then all the different functions. So I'm not going to go through all this. I have a document that I'll be posting to the knowledge base shortly that goes through all of this. Just know that we're looking at one piece of a bigger puzzle today. And in that piece that we're going to be looking at is 1A, so this scenario here. We also have 1B and then option 2. So this is network camera recording using an Axis camera. And if we look at this picture, what we've got is a standard CPU connected with the front port to a hub, to a switch, going out to the Axis camera. That Axis camera can be storing data internally on an SD card or with a network share. And in this case, we're using our PC, just a shared file on our PC. So what the CPU will do is go out to the camera, and first it will set the time of the camera, and then secondly, it will tell the camera when to record images to push them to the shared server. The CPU will also do logging, so we'll do CPU logging, and then it will match those two up, so the video file and the logging file will be synced. In the coming phases, we'll have a new product, the RD81 RC96, which will actually record 100% of all CPU devices. So in this situation with your current CPU, we can't get 100% of the devices. When we add this new module, we'll be able to get everything, all the Ds, all the labels, all the Ms, everything in there logged constantly with this module. So that will be coming soon, and when we get that, then the CPU will, it's new hardware, so the CPU will have to be upgraded. And then the final phase will be getting sometime next year an update to that module. So this is, we call the recorder module, and the update will be called camera recorder module, so we put a CA at the end. That not only records everything in the CPU, all the devices and labels, but it also can record the camera images. So it will trigger the camera and store locally in the SD card, and the benefit there is everything is in one central location, so it makes it that much easier to compare what was going on with the video feed to what was going on in logic. This is a little bit blown up view. So we have a standard CPU, which I'm showing here. We have the switch. I've got a PoE switch running to an Axis camera. Again, my storage is my PC. So that is basically this, the CPU will be telling it what time is it, so that they'll be time synced, and then when to record. And I've got an E-stop here that I'm feeding in, not a safety E-stop because I don't have a safety CPU, just a standard CPU is all that supports this function for now. So this is just wiring into an input. So when I press this E-stop, we should get a fault, and we should be able to see that fault. I've also got a GOT here showing with a button to trigger the set time of the camera, as well as to do a simulated fault. So I can either do a fault from physical e-stop or a fault from here to tell the camera, please record the data. And then we'll see the fault M1, That will be our trigger to do CPU logging, and that will be our trigger to do camera capture, and then we can reset and try the simulation again. So with that, let's go ahead and take a quick look at this solution. Here is the logic. I'm not going to go through the logic. It does rely on two free function blocks. One function block sets the time, and the other one will trigger the camera to take images. So let's get started. I can see that I'm connected to my camera. See, I can wave in front. I can zoom in if I want, and I also have, this camera has PTZ action. And in the future, I'll be able to control this PTZ and zoom. When the camera recorder module comes out, this will all be controlled in the CPU. But we can see we're connected. We've already got our established system going to a storage. Again, it's going to a local folder called Access Videos. I made that a shared folder. Here is my Access Videos just on my C drive. So that will be where all of the videos are stored. Okay, so now that we've looked at the setup, let's go ahead and trigger using the HMI. So if we were to simulate a fault, we press the button, we've got M1 on. We know M1 is our CPU logging trigger, and M1 is our camera file recording trigger. So that should have given us a file from the camera as well as a logging file from the PLC. So we'll take the fault off, we clear the fault, and we say let's go back and look, see what actually happened. First we'll bring up the video verification tool, and let's open, and we'll point at our video file, Access Videos. Basically I made a shortcut in each one of these folders so I can flip back and forth, so I can go to my FTP files, the logging files, or back to my video files. So I go to my video files. Here's the folder, Access Camera. 2020 August 5th, that's what we want. 11 o'clock, that's what we want. And then I'm just going to choose the latest folder. So I double click and pull up this file. And what happens is now I can play this action, and I should see that I triggered the screen right about there. And I'm capturing about 5 seconds before and about 5 seconds after. And you can see I'm still talking about the M1 trigger. So that video file captured, so perfect. So the function block inside the PLC went out and captured this video file. Within here we could also put logging markers if we wanted, so I could add a marker here and maybe here as points of interest, and I could flip back and forth between those and watch the video update, just see if there's something else going on and to remember those. If you add a log marker file, that actually adds information to the folder that this file is located, and it will remember this from here on out. Now let's look at GX Works3. So if we come to this new tab, this new recording tab, brand new for GX Works 1.065, let's start offline monitor. So that's the main function, offline monitor. And recording file would be if we have the recorder module or the camera recorder module where we're capturing 100% of all the devices and labels. We don't have that. We either have to choose logging file or memory dump. Memory dump's going to be all the devices, all the standard devices, just at one point. So it's a dump of all the memory, but only one time. So the logging file is what I'd recommend. That's what we have set up. So we say logging file, we go to our logging folder, go all the way to the end, find the last binary, 1108. So that's the one we want. So we double click. Do you want to start? Yes. And what it comes up, you'll see we have a seek bar. We're basically in an online state, but it's actually offline monitoring. So this isn't monitoring the PLC, this is monitoring the logged file, the logging information. I've got 30 records before the event and 30 after. So if I come in here, I can say take me to 30, and M1 is still off. But if I give one click here, so this will go to 31, M1 is on. So M1 was my trigger. I've got 30 records before and 30 records after. And again, I can click back and forth on the seek bar and see see what drove my M1, and it was the fake alarm M0 from the HMI. So pretty cool. Now what I can do here is say, okay, that's about where it happened. Maybe I want to go exactly to 31 and say that's exactly the point that M1 turned on. Let's add a log marker, right? So now that's always there. At any point, I can jump to that position. Maybe I want one at the very beginning, add another log marker here, and all the way at the end, add a log marker here. Those are permanent. Those stay with that file. So if we go back to the video verification, let's go ahead and delete these markers in here. So I've got no markers, right? A blank slate. Let's read the log marker file, and this time I'm going to read the GX Works3 log marker file. So I can come and find that in the log folder. So I need to jump to the log folder. There they are. All the way to the end, I'll see these LMS files, log marker files, and I want the last one that I created. Again, that's why it's so critical to know the timestamp and have the CPU synced with the video file, because you're going to be looking at the date and time down to the second to match these up. So when I open this, now I see that I have all three of those log markers all grouped real tightly together. So if I use this, I can go to the first one. I'm just about to press it, click it again. Nothing has actually changed because it happened so fast. And then click it one more time, nothing has changed. So all three of those are all grouped really tightly together. So on this time scale, I only have 60 records, and that's a record every CPU scan, so it's happening very, very fast. If I come here, it's 11:08:54:553, and this is 11:08:54:570. So not even a whole second has gone by, and here I've got 10 seconds of data. That's why they all look grouped together. I could blow this up a little bit and kind of see that there's a couple in here, but I really don't know that until I hit this. So another key point of this is you may want to match your logging file time to your camera time so that they're on the same time scale. Anyway, that's what that log marker does, is it links these up. Now, while I'm in here, I could click on any one of these devices and say, give me, or I'll right click and say, give me the wave display. This is going to open up GX Log Viewer. Now you have to do that. You can't just open GX Log Viewer. You have to open it from within here, because then it will match up and we'll see that GX Log Viewer is now looking at our CPU offline monitor mode. This is the logging data, same as what I pulled up in here. This is the exact same logging information. And what you'll notice is if I move this bar, let's link this here and this here. As I move this bar here, this line is changing. So at any point I can say, maybe I go to my log marker file, and sure enough, when I look at M0, that's the button I pressed. So these are linked, so I can move it here and it reflects here, and I can move the seek bar here and it reflects here. So again, I'm syncing offline monitor of the ladder logic, all the devices that I logged, with the actual GX Log Viewer. And of course in Log Viewer I can always do overlays, switch these around, change the colors, etc. So pretty powerful stuff, matching not only a video file but actual logging information, offline monitor, so ladder monitor, so I can see M1 changing, and they're all synced with log marker data. And then of course the last thing to show is if I right click, I can say data flow analysis, and that will take me through what triggers M1. I can either come from X0, the e-stop, or from M0, the fake alarm, and that will take me directly to that location. So that's how data flow analysis comes into play when we're in offline monitor mode. And then I can see that M1 triggers this function block. This is the event trigger function block. Okay, very quickly, I'm just going to show one more time. Come in, hit the e-stop, we get our fault, release the e-stop, we can clear the fault. So that should have recorded. And so now let's go see if that did. First, again, we'll check our video file. So we want to switch to the video folder. 11 o'clock. We got a third folder here. That's a good sign. We open it up. And if we come about in the middle, there I am pressing the E-stop. And again, I can click individually through each one of these frames and see the exact moment when I press the E-stop, or if you had equipment problem, maybe something jammed, maybe a proc switch or a dog didn't get made, the product was incorrect going down the line, whatever it may be, you can see that exact moment in time. And I come into GX Works3, I already have, I'm already in offline monitor mode. I actually have to take myself out of that mode, so I say stop, and then we can go back in by selecting the new logging file that we just created. We're in the log folder, come back down here, B6, 42B6, that's the latest, and we can jump right to this point and see M1 turned on, and that was before and after. So basically we didn't have the E-stop, and as we move through the frames one at a time, we can see the E-stop came on and M1 came on, giving us our file. That summarizes the system-wide recording and the simplified analysis. Again, it's step 1A, a very small piece of this picture where we have a CPU you can use off the shelf. You can test this now with an access camera, either with a PoE switch providing power, or some access cameras have their own power, going to either a SD card on the camera or to a network share, and you could see this functionality. Thank you for your time. Hope you enjoyed the video, and I look forward to showing you steps 1B and step 2 in the near future.